Hello students, today we are going to study reactions of amines. In the previous lecture we have seen that alkylation reaction. In that reaction hydrogen atoms attached to that nitrogen of amines are replaced by an alkyl group. Then acylation reaction. In that reaction hydrogen atoms attached to that nitrogen of amines are replaced by acyl group, and for that purpose we have to do, or we have done that reaction, that acylation by using acetyl chloride, acetic anhydride, and then benzyl chloride. Then a reaction with nitrous acid. Before that, reaction with carbylamine reaction. That reaction is given only by primary amines. Primary amine plus chloroform plus alkali like KOH, that gives alkyl isocyanides with foul smell or offensive odor. And lastly, in the previous lecture we have seen that reaction of primary amines with nitrous acids. Aliphatic and aromatic primary amines, they react with nitrous acid, that is HNO2. That HNO2, that is unstable compound, that is prepared by using the reaction of that NaNO2 and HCl. And that gives benzene aryl diazonium salts. If we have taken aromatic amine like aniline, that gives benzene diazonium chloride, or that is known as diazonium salts. Now in today's lecture we are going to study a reaction of that diazonium salts. The formula of diazonium salt is like this: ArN2X. This is aryl diazonium salt. Now it gives different types of reactions. So particularly the reactions are divided into two types. Reactions due to the displacement of that diazo group. In that, first of all, we will see that reactions in which there is a displacement of that diazo group. Means that diazo group is replaced by different atoms or groups like chloride Cl, Br, I, F, Cn, hydride, that is H minus, hydroxide OH minus. Now, first of all, we will see that replacement of that diazo group by Cl, Br, and Cn, and that reaction is known as Chandler's reaction. The first reaction that is known as Chandler's reaction. In this Chandler's reaction, just I'm going to take general examples like here ArN2X. It is aryl diazonium salt. Aryl diazonium salt. Now this aryl diazonium salt on a reaction with CuCl and HCl, it goes on reaction with that CuCl and HCl, it goes. Now this much part, this AN2X, it is replaced by this Cl, and it gives ArCl plus N2 gas is given out. That is diazo group is replaced. It is known as aryl chloride or chloroarene. If, for example, we are taking here C6H5N2Cl, it gives C6H5Cl plus N2, that is chlorobenzene. मी इथं फक्त जनरल एक्झाम्पल घेतोय तुम्हाला. इथं C6H5N2Cl वाटतं एक एक्झाम्पल घेऊन दाखवतो. इथं घेऊन दाखवतो तुम्हाला या पद्धतीने रिएक्शन समीकरण करायचं. C6H5N2Cl Again here in the presence of CuCl and HCl, it gives C6H5Cl plus N2 gas is given. This Cl is added to this C6H5 group and this N2 gas is given out. It is known as chlorobenzene or phenyl chloride. Aryl chloride is phenyl chloride. Chlorobenzene is obtained. It is Sandmeier's reaction. Now, similarly, we can prepare aryl chlorobenzene. Instead of that chlorobenzene, similarly we can prepare bromobenzene. For that purpose, here ArN2X. Now, it is to be treated with CuBr HBr. Now this N2X group is replaced by, it is diazonium salt, aryl diazonium salt, or we can say diazonium salt, and use ArBr plus N2 gas, that is to be given out here. Here ArX, that is haloarine or phenyl halide. In this way, we can prepare here Br, chlorine. Now here it is X is replaced by here 2X is replaced by this bromine. It is bromobenzene. Just to try to give an example like this, I am going to take here only general examples. Then again ArN2X, we can convert aryl diazonium halide into cyanides CuCN plus HCN, then it gives CuCN plus HCN. It gives ArCN plus N2 gas. In this way, we can convert all these are nothing but examples of Sandmeier's reaction. Here in this Sandmeier's reaction, we have here CuCl, HCl, CuCl, HCl, CuCl, CuBr, HBr, CuBr, HBr. ज्यावेळेस आपण घेऊया त्यावेळेस हा एक ग्रुप Br ला रिप्लेस होईल. Then CuCl, HCl, that gives ArCl. Now then after that, it is regarding about the Sandmeier's reaction. Then Gattermann reaction. In that reaction again, second type is Gattermann reaction. In this Gattermann reaction, same product is obtained. Chlorobenzene, bromobenzene, and iodobenzene is obtained. But just you have to replace this reagent. Instead of this CuCl and HCl, we have to use here. Instead of this CuCl, we have to use copper powder. Means CuHBr. The same reaction is there now. ArN2X. Again here reactions. Means just you have to replace this CuCl by Cu and then HCl, copper powder. When this aryl diazonium salt, it is aryl diazonium salt is treated with, it is aryl diazonium salt is treated with copper and HCl. Then it gives phenyl chloride plus N2. Reaction same as Sandmeier reaction and Gattermann reaction same. Just instead of that CuCl, we have to take here copper powder or copper. Then ArN2X, again same N2X. By using this reaction, we can prepare bromobenzene also. Here we have to take here Cu/HBr and it gives Cu bromoarine plus N2 gas is given out. It is bromoarine. It is here. It is bromoarine. It is aryl diazonium salts. मी फक्त जनरल रिएक्शन्स घेतोय. तुम्हाला हे एक्झाम्पल प्रत्येकाचं लिहायचं आहे. C6H5N2Cl घेऊन रिएक्शन प्रत्येक वेळेस करायची आहे. देन by using this reaction, by using this Guterman reaction, we can prepare also iodoarenes or here bromoarene, like that iodoarene ArN2X on heating with this potassium iodide here now. Where is the difference here now? Now reduce this much part is replaced by iodine iodoarene plus N2 gas is given out. This is iodine. Now these three are the examples of Guterman reaction, and these three are the examples of Sandwich reaction. Here difference in these two reactions is that just we have taken here CuCl, and here instead of that CuCl we have taken copper powder, that is copper and HCl, copper and HBr and potassium iodide. Now the third reaction of that benzene diazonium salts, arene diazonium salts, that reaction, that is mild reduction by using reducing agent like H3PO2. When that arene diazonium salt like ArN2X is reduced by using this reducing agent like this H3PO2 and followed by H3PO2 and water. Here now, here formula of water is like H3HOH. This hydrogen atom is attached to this ARH. It is arene or it is formation of benzene takes place plus N2 gas is given out. Addition of hydrogen, that is known as reduction. Addition of hydrogen, this reaction addition of hydrogen takes place into this diazonium salt. Therefore, it is a reduction. It is an example of mild reduction. Here it is diazonium salt on reduction with by using that H3PO2 and H2O use arene. If we are taking here C6H6N2Cl like this, example, for example, C6H5N2Cl. This on reduction by using this H3PO2 hypophosphorus acid and water gives. Here now this hydrogen atom attached to this C6H5 means it is converted into C6H6 plus N2, it is benzene. Here formation of benzene takes place. How will you convert benzene diazonium chloride? The name of this compound is, it is benzene diazonium chloride. Diazonium chloride is reduced by using H3PO2 and water, H2O. Then benzene is obtained. How will you convert benzene diazonium chloride into benzene? Such type of the question that will be answered. Then you have to write this answer, you have to write this reaction. Now it is mild reduction by using H3PO2. There is another reducing agent that is also used, and that is reduction by using ethanol, C2 by using ethanol, reduction by using ethanol. Here now, when this arene diazonium salt, ArN2X, is reduced by using ethanol means CH3CH2OH. Now what I was saying, then we use is reduced by using C2H5OH. Then again here, one of the hydrogen atom from this OH group, it is attached to this ARH. Use ARH. Again it is benzene or arene. Arene, that is a general word, general term. It is arene diazonium salt. It is arene diazonium salt. Now it is again here. One of the hydrogen atom from this CH2 group that combines with this CX formation of HX takes place. And now what is remaining here? These two hydrogen atoms are removed from sulfur, therefore it is getting converted into aldehyde CH3 CH double bond O. In this way we have to write the balanced reaction here. When arene diazonium salt is reduced by using ethanol, then arene is obtained. Here, suppose for example, you have to write the example below this: C6H5N2Cl in the presence of ethanol, it is getting reduced into C6H6 means benzene plus HCl plus acetaldehyde. And then one more, that will be the last one, reaction with H2O. The third and then fourth and the last reaction is reaction with H2O, and that is formation of phenol. That is formation of, here in this reaction there is a formation of phenol takes place when that arene diazonium salt is heated up to 285 Kelvin with water. Here now Ar(N2X), it is arene diazonium salt. If it is heated with water, then reduce. If it is heated with water, then reduce up to 285 Kelvin temperature. Temperature condition is there. Here reduce. Now here H2O means HOH. Now here this much part OH group, it is attached to this Ar, and it gives AROH. It is phenol or aromatic phenol. It gives AROH plus this phenol plus N2 gas is given out plus this hydrogen atom combines with this X, and formation of HX takes place here. In this way, how will you convert diazonium, arene diazonium salts into aromatic phenols, benzene diazonium salts? How will you convert benzene diazonium chloride into phenol? असं जर विचारलं तर तुम्हाला इथं C6H5N2Cl घ्यावं लागेल, आणि इथं C6H5 means it gives phenol plus N2 plus HCl, and you have to write that balanced reaction. Then after that, there is one more reaction is remaining of that primary amines, is that reaction with arene sulfonyl chloride. Reaction with arene sulfonyl chloride. That reaction is also known as Hinsberg's test, and that test is used to differentiate or distinguish between primary, secondary and tertiary amines. Reaction with, now another one more reaction that is remaining, reaction with arene sulfonyl chloride. Arene sulfonyl chloride. The formula of arene sulfonyl chloride is like this: C6H5O phenyl, here C6H5O, here SO2Cl, arene sulfonyl chloride. This reaction, I think it is the fifth one. This reaction is known as Hinsberg's test. It is also known as Hinsberg's test. And how will you distinguish between primary, secondary and tertiary amines? By using Hinsberg's test. That type of the question that will be asked in the examination for 3 marks. Then first of all, we have to do the reaction of that primary amine with arene sulfonyl chloride. See, we will see here one by one. Now, first of all, we will see here 1 degree amines means primary amines. When primary amine like ethyl amine, just I am going to take an example like this. I am not taking a general reaction. When it is ethyl amine, C2H5NH2, it is ethanamine or ethylamine. Ethanamine, it is the IUPAC name. Ethylamine is the common name. When this ethylamine is treated with benzene sulfonyl chloride, here C6H5 किंवा आपण याला असे लिहू शकतो C6H5 SO2Cl किंवा पुस्तकामध्ये सुरुवातीला C6H5 इथे इथेनॉलच्या ऐवजी सुरुवातीला तो रिएजंट घेतलाय तसं लिहिलं तरी चालतं किंवा मी लिहितो असेल तर रिएक्शन तीच येते हिअर लाईक दिस बेंझीन सल्फोनिल क्लोराइड C6H5 SO2Cl plus primary amine like C2H5NH2. It gives now when it is treated with it is benzene sulfonyl chloride. It is benzene sulfonyl chloride on reaction with this ethylamine or ethanamine. It gives now see here reaction very simple. This hydrogen atom, this one of the hydrogen atom which attack this hydrogen atom combines with this chlorine. Formation of HCl takes place, and we will get here the compound like this. We will get the product like this C6H5 here SO2 this much part C6H5 SO2 that remains as it is. Here now this sulfur it is directly attached to this nitrogen atom NH here C2H5 it is known as now it is sulfonamide benzene sulfonamide it is ethyl group is attached to that it is N-ethyl sulfonamide is obtained. Now this N-ethyl sulfonamide it is acidic in nature. This compound is strongly acidic in nature. Why it is acidic in nature? Because there is a now here nitrogen atom it is attached to this hydrogen atom. Now it is an electron with the drawing group. SO2 group is an electron with the drawing group, and this nitrogen atom contains one hydrogen atom, and therefore the nature of this hydrogen atom it is acidic in nature. Therefore it reacts with this much part, this N-ethyl sulfonamide, it dissolves in alkali like KOH. It dissolves in alkali like KOH. हे acidic nature आहे जर म्हणजे KOH सोबत मध्ये KOH मध्ये डिसॉल्व होईल हा हायड्रोजन जो acidic असल्यामुळे KOH मध्ये OH combine with this to be converted into potassium salt. Potassium salt मध्ये हा compound convert होईल. Therefore it is acidic in nature due to the presence of this hydrogen atom on the nitrogen. And now it is related to primary amines. Primary amines use N-ethyl sulfonamide. It is acidic in nature, and it is this compound dissolves in alkali like KOH. Then another secondary amines. When secondary amines like diethylamine, here I am going to take your example that is diethylamine. There is no general reaction. जनरल रिएक्शन नाही आहे इथं आपण घेत नाही आहे. जनरल रिएक्शन दिलेली आहे पुस्तकामध्ये आपण जसं पुस्तकामध्ये जसं दिलेलं आहे त्या पद्धतीने जात आहोत. When this benzene sulfonyl chloride is treated with diethylamine, the formula of diethylamine is like this C2H5H. Here now again here this hydrogen atom combines with this Cl, it is diethylamine or N-ethyl ethanamine. It is diethylamine, it is ethylamine, it is ethylamine, diethylamine. It is again benzene sulfonyl chloride, benzene sulfonyl chloride. It gives, now it gives here. See here now, this much part, SO2 group, it is the electron driving group. SO2 group that remains inside. Now this sulfur atom, it is attached to this nitrogen atom, and H, and here nitrogen is attached to two ethyl groups. It is again here N ethyl N diethyl sulfonamide. N diethyl, nitrogen attached to two alkyl groups, ethyl group. Therefore, it is N diethyl sulfonamide is obtained. Sulfonamide PHO है कि FO सुद्धा दिलं जातं SeUl FO NaMide. N diethyl sulfonamide is obtained plus HCl. Now this compound it is not acidic in nature, or it does not react with alkali like KOH or NaOH. Why? Because there is no hydrogen atom present on this nitrogen atom. याच्यावरती नायट्रोजनवरती हायड्रोजन नाही आहे. हायड्रोजन जर असता तर त्याचं नेचर कॅरेक्टरिस्टिक त्याचं ॲसिडिक व्हायला असतं, म्हणून तो ॲसिडिक झाला असता. पण इथं नायट्रोजनवरती हायड्रोजन नाही आहे, म्हणून हा कंपाऊंड ॲसिडिक नेचरमध्ये नाही आहे, म्हणून हा केवळ सोबत रिॲक्ट होणार नाही. पण प्रायमरी अमाइनमध्ये मिळालेला मात्र हा हायड्रोजन असल्यामुळे हा ॲसिडिक हायड्रोजन आहे, हा अल्कलीसोबत रिॲक्ट होतो. जस्ट सिंपल रिएक्शन्स आर देयर, यू हॅव टू रिमेंबर दिस टू. देन टर्शियरी अमाइन्स. टर्शियरी अमाइन्स. Tertiary amines. When tertiary amine like triethyl amine, here again benzene sulfonyl chloride C6H5SO2Cl plus C2H5 3N, and here is no reaction. You have tried the reaction like this. No reaction. Why there is no reaction of this triethylamine with this benzene sulfonyl chloride? Because tertiary amines, they do not react with benzene sulfonyl chloride, as they do not contain replaceable hydrogen atom on this nitrogen atom of or tertiary nitrogen atom. Therefore, there is no reaction with this benzene sulfonyl chloride. In this way, we have to write this Hinsberg test. There are different. First, primary amines gives N-ethyl sulfonamide, secondary amines gives N-diethyl sulfonamide, and tertiary amines they will not react with benzene sulfonyl chloride because there is no replaceable hydrogen atom present on that tertiary nitrogen atom. Okay. Thank you. With this we have completed this Hinsberg test. Okay. Thank you. Today stop here.